Good morning or good afternoon, I guess, for many people. Welcome to Spantech Products seminar on the servicing of instruments for the detection of ppm level gases, and particularly welcome to Paul Kimberley, who will be our speaker, who I'll introduce properly in a minute. First of all, I'll encourage you to use the chat box, which a lot of you are using already. Say hello, let us know, whereabouts in the world you are as well. Not just say good morning. Interesting to see where people are calling in from. I think it's going to be very global, but well, I can already see Abu Dhabi and Sri Lanka mentioned, and other such places, and Calcutta I can see as well from my personal knowledge. So and Chile, so we're currently spanning most of the world, which is great. Even Cambridgeshire, which is brilliant, which is pretty much where I'm speaking from, give or take 1 mile, technically Bedfordshire. Yeah, it's brilliant to see such a global attendance. A lot of you will know Spantech products. If you don't, I've got one slide here. I will present a short series of slides at the end. But we are in the UK. Our headquarters in Surrey, UK. I'm based in the office near Cambridge, and founded back in 1977 by my father, and Dr. Chandramani Narain, and based in South Godstone, Surrey, with a lot of our sales going overseas, and hence the international flavour of the audience. And that'll be, I think, not news to a lot of people on the call, but for those of you who don't know us, that's the basic company background. I'd like to introduce to you our main speaker for the day, for the event, which is Paul Kimberley. Paul is the Managing Director and founder of Point Safety here in the UK. Point Safety are based in Southport, which is just above Liverpool, and not far from Blackpool, I guess, on the northwest of England. And they have a fantastic operation covering national and international customers, and we've worked with Point Safety for a number of years in various ways, and obviously they are one of our very much trusted partners. On that note, I'll let Paul say the rest. So Paul, welcome. Thank you for doing this, and hand over to you.
Okay, thank you, Chris. Thanks for the introduction, and good morning to all you guys attending today. Again, as Chris mentioned, I am Paul from Point Safety. So firstly, I'd like to give you a bit of an overview of the subjects we'll be going through today. The topics we'll be going over this morning in terms of gas detection and the role of servicing these instruments. Firstly, we'll give an introduction to Point Safety and what we do. Secondly, I'm going to go over gas detection today, portable gas detection, and the different types of detector and their applications. I'm not sure the level of knowledge, so I've kept it fairly low level in terms of from a technical point of view. Then we're going to look at different types of sensors within these detectors and what they use to detect. We will then look at why we need to service, followed by the international standards within gas detection. I'll then cover the equipment that is required to carry out the servicing, then the consequences of not carrying out effective servicing and calibration, and then we'll finish off with typical types of consumables that are required for the service activities and any other key considerations. So we'll move on here. So just point safety. We were formed back in 2011. So we're looking forward to celebrating our 10th year this coming May. 9 years, and then 1 year under coronavirus. So it's we've all got through it. So that's great news. And then as Chris mentioned, we're based in the northwest of the UK, in Southport, but we do supply internationally and throughout the UK, and internationally supply and service. We specialise in all gas detection, sales and service activities. Field service engineers we have throughout the UK. We've got a service centre and distribution hub for new sales and return service, again based in Southport. We're main distributors and credit service centre for many of the major gas detection suppliers and manufacturers, brands including Honeywell, BW, Crowcon, MSA, Scott, Blackline, Analog and Industrial Scientific. So we do cover 90% of the market. So what is it we do? So our services probably break down into 5 main areas. So portable gas detector sales. We supply the full range. We'd like to understand our customers and what their requirements are for a specific application, and then we'll try and tailor which make, which model, which type of gas detector that they will require for their activity. Then we support these gas detector sales with portable gas detector service and calibration. So our team here in Southport will deal with all warranties, repairs, ongoing service contracts, sensor replacements, calibrations, and data logging retrieval for our customers. We then have our division that specialises in the installation of fixed installed systems, and which is primarily a project-based part of the company. So we go into factories and manufacturing facilities across many industries and install fixed gas detection products and carry out the commissioning on those. And then on the back of that, we tend to create a service contract which is bespoke for the client, depending on frequency and service level, on the amount of support that they need, or we will support their existing engineers in-house. So moving on, I will just touch on the types of different portable gas detectors that there are in the market. So there's a number of different options available, just depending on your circumstances or requirements. Firstly, we've got single gas disposable monitors or limited life. So typically these will last between 2 to 3 years from turn on. Typically they will not have a reading. They will just monitor an alarm at a specific set alarm levels, for low, high, STEL or TWA. Generally, as I say, 2-year life, possibly 3 depending on the sensor. You turn them on, you use them. They generally don't require calibration, but they do require regular bump testing, as it is required by most gas detectors. You will then move on from the single gas, because single gas is generally only available in 3 or 4 different sensor configurations. We'll be looking at H2S, CO, oxygen, SO2 primarily, and then we'll move on to single gas serviceable instruments, like the second one here on the screen. These are a little bit more in depth. They generally will have a instant reading on the screen. They'll be available in a myriad of toxic gases, and some manufacturers do flammable and PID in single gas as well, for VOCs and volatile organics. A vast range is available for most applications. We'll then move on to multi-gas disposable. So a multi-gas disposable will generally be 4 of your standard sensors for confined space entry, of carbon monoxide, again, hydrogen sulfide, a flammable sensor, and an oxygen sensor. The disposable is designed primarily for large compliance markets where they do not want charging on a regular basis, and they do not want their employees to make executive actions on it. It's a runaway meter, so if the meter alarms, they will vacate the area, so they don't need to know the concentrations being reached. They just need to know to leave the activity they're doing. You'll then move on to what is your standard multi-gas. It says on here disposable, it should say serviceable. So these have again your primary sensors with the options of additional sensors within there, additional toxics. Some may have the ability to have VOCs in, but most of them are standard 4-gas meters. But you can replace all the relevant sensors. They will require calibration on a maximum of 6 monthly intervals. Again, bump testing is advised on a daily basis if possible. You'll then move on to multi-gas pumped units. So these are more for sampling and pre-entry checks prior to entry of a confined space, a vessel, a tank, or any other area that you want to gauge the concentration of gases within before entry, using followed by entry with a portable monitor. And then you go up to your 5-gas and PID options. So these are your most versatile, larger meters. They've got the option of pumps. They've got the option of probes. They've got a far greater range of sensors available to them across all the toxic range. The PID, infrared sensors for CO2, different types of sensor technology for their flammables, and they also have PID and VOCs available to them. So that's pretty much across the range. I've picked out Honeywell's product line here, but pretty much each manufacturer will have a line that supports the same categories across those areas. Now, from again, portable sensors will have gas detection sensors within them of different technologies. Firstly, you'll have electrochemical sensors. These will be typically for your toxic gases and your oxygen sensors. They'll read in ppm or percent volume if it's oxygen. They're your very stable sensors, normally with a life between 2 to 5 years, depending on the gas. Some of the toxics do only have 1 year life, so that's important to recognize when you're looking at service contracts and ongoing servicing requirements. Then when it comes to flammables, most of your portables will contain a flammable blister sensor, which will measure in percent LEL, but you have to bear in mind that these will need oxygen or air in order to combust within the sensor to create their reading. We would then have infrared or IR sensors. IR sensors are used again for flammable gases, but also CO2. 99% of all CO2 sensors will be infrared, and they also don't require O2, oxygen in order to function. So in inert atmospheres or blanking at the top of tanks, they will still pick up the flammable gases without the requirement of oxygen to be in the sample. But when selecting these, you need to bear in mind that they will not pick up hydrogen. So if hydrogen is a requirement, you will need a ballista, or at low levels an electrochemical, and detecting hydrogen with at ppm levels. Fourthly, the last main detection method will be PID, which is photoionization. So these sensors have a PID electrode and bulb within. They detect in ppm for a range of volatile organic compounds. Now, they're a broad spectrum sensor, so they will pick up a vast range of VOCs within the area. So it's important to understand what VOCs that are present are likely to be present to ensure you're setting up your meters to detect for the most volatile of these when determining which monitor to select. So that just gives us a brief overview of what types of sensors were within those range of meters we had before. So why do we need to service these instruments? Why is it important? So primarily, gas detectors, they require ongoing maintenance throughout their lives. Again, as mentioned before, this is reduced for disposable units, although they do still require bump testing, which I'll go on to in a moment. But it's in general, servicing activities revolve around 3 core areas that will need to be undertaken. Functional testing, or bump testing as it's commonly known. This is a quick test, and it's carried out on the detector with a small amount of equipment or a docking station if available. So a bottle of test gas and a regulator and a bit of tubing as shown in the picture, which will apply a known value of gas that will push the meter into its alarm state, and this will confirm that the meter will respond to the target gas if it does come across it in its daily activities. Most of especially the toxic meters, they read at 0, so you will never know if they're going to pick up their target gas unless you regularly apply a target gas to ensure that is the case. So it is a best practice. Not everyone does implement a bump testing program, but it's highly recommended. And if any of yourselves or your customers do not have one in place, then I think you should start considering it and advising it to your customers. Ourselves or Chris and Spantech are more than happy to go over what gas requirements you may need. Secondly, one of the most important parts of the process is regular calibration of the instruments. So this is carried out. Normally, manufacturer recommendations are a minimum of 6 months, although depending on the area that you are working in and the environmental conditions, the background gases that are in that area, you may deem that this needs to be carried out more regularly. Again, by the results that you're getting from the calibrations will show if there's been any drift on your sensors, particularly the flammables. So it's important to carry this out on a regular basis. Again, gases like H2S are very, very toxic, and at high levels can cause death with a single breath. So it's important that the readings that we're looking at on our meters are trusted from that purpose. It's quite a straightforward process nowadays, calibration. I'll go through that with the equipment that's involved and the time that takes to be carried out. The third activity in servicing, main activity, will be sensor replacements. So each sensor has a defined period and must be replaced after this period runs out. The average life of a typical sensor is approximately 2 to 3 years. Although this does vary. Some of your most volatile gases will have a sensor life of a year. Now, typically, oxygen sensors will last up to 5, and flammable sensors can last longer if calibrated and serviced regularly. Again, the importance of calibration and bump testing is that, especially on the catalytic bead or polyester sensors, they are liable to get affected by poisoning, especially from silicones within the atmosphere. These create like a glass film over the catalytic bead within the sensor and stops the gas being absorbed. So it's important to be testing and bump testing these regularly to know if that has happened, and your detector is no longer providing the protection you require. Depending on the type of device, sensors may be replaced individually or as part of an integrated cartridge. We're seeing more nowadays that they are individual sensors, but in the past there has been a number of meters with cartridge variants that have 2, 3 or 4 sensors within that cartridge, and you replace them all together at the same time. So if you're looking at implementing a bump testing or calibration procedure, then there's two basic ways of doing it. For the most basic, you'll require test gases, a regulator, so a fixed flow regulator, normally 0.3 to 0.5 liters per minute for applying the gas to your monitor. You'll require tubing. And for some devices, many nowadays, you'll require the manufacturer software for that device in order to make any changes or to change the span of your detector. One other thing that isn't included on that list is actually a calibration cap. So each detector will need a calibration cap that's suited to the detector, which will go over the front of the monitor where you apply your tubing. And this is individual to the meter. So each meter you're selling, you'll need those calibration caps in order to carry out a basic calibration. The same setup's required for bump testing. You don't necessarily require the software. Also, again, bearing in mind the types of gases that you are detecting within that meter may require different types of tubing. PVC tubing is suitable for a lot of gases, but some of the sticky toxics, your chlorines, chlorine dioxides, they will require Teflon tubing in order to ensure that they don't the reading and the concentration of the gas going through the tube isn't distorted. If you have a number of meters or you're carrying out a service operation, then you'd probably start considering using automatic bump and calibration test stations. Most meters now will have the option of a bump and calibration station available to them, depending on which one. So you would require to purchase a calibration station for each type of device that you were looking to calibrate, and each type of model. The benefits are it's fully automated. You will apply the meter into your dock. You'll close the lid and you'll press a button of bump or calibrate. It will then, using a demand flow regulator, it will draw the gas from your mixture. into the docking station. It'll apply that to the meter. It will carry out all the calibration adjustments that are needed, and then it will tell you whether it's passed or failed. Normally, if it's failed, it'll be a blocked sensor, a blocked filter, or it could be the sensor is no longer working beyond its economical life, and that will also transmit to the relevant software of the dock that you're using, again creating your records of calibration. Possibly other items, including asset management, might be included in that. Again, moving on to international standards. Every country and every region will have independent international standards, national standards relating to the use of gas detectors. So we won't really go into that area, but each instrument will have a rating for ATEX for zoned areas. Typically 90% of units are used within zoned applications, or the potential for zoned areas. So you will find that most instruments are rated for at least ATEX Zone 2 and above. Again, there's MED shipping approvals for certain meters if you're involved in the shipping market, which is like the little ship's wheel on the back of that instrument. That'll demonstrate that the meter has been approved for shipping and applications and marine applications. All instruments will have an IP rating, normally IP 65, 66 and above, for water ingress. When we come to the calibration, the accuracy of each calibration is not really based on the equipment. It's based on the test gas that we're using to calibrate and bump those meters. So it's vitally important that you are purchasing your test gas from a reputable supplier like Spantech, as all their test gases will be batch traceable. They'll be traceable to national standards, so it's very important we use those correct gases, that we can rely upon their concentration, and that gives us a line back to national and international standards there. Krish, when he's talking about the individual canisters later on, I think has got a few pieces to say on the gases that they supply. So what are the consequences involved with not actually servicing your equipment or servicing it irregularly? So basically, personal gas detection and its performance is life critical. So if monitors fail due to poor performance or lack of maintenance, then this can lead to exposure events, injuries, and ultimately fatalities. So there's life consequences, and there will be cost consequences that come from that. So these involve health and safety litigation. If you've had an incident on your site, there may be a lot of investigation that goes into that will cause downtime, plant downtime in the event of that accident. And also it's important that the instruments are serviced regularly, because you may also find that you are prevented from running plant or bringing it into more plant downtime if they're not functioning correctly when you're expecting them to. Again, poorly maintained equipment, like with everything, will shorten the life of the monitor, so giving a lower life cycle cost to yourselves and your customers. So it's important to keep up those frequencies. Contamination of the filters, the drift that we've talked about on sensors, will lead to poor servicing, will lead to increased or decreased periods for sensors, so increasing that lifetime cost of the monitor. So in all service applications, there's a few typical parts that are generally replaced more often from a service point of view. So again, the sensors we've talked about there with their life expectancies, you would try and replace these prior to them failing and in line with their expected life. Again, they will have filters, internal filters for the sensors, which do get dirty and clogged, which need to be replaced to keep the performance up. And I'd always recommend external filters that you would go over the top of your meter that can be changed more regularly by the user, especially when they're working within dirty environments, mining, construction, waste. They do get clogged, and this protects the internal filter. Alligator clips on most instruments do tend to be one of the most frequently replaced items. Very easy to do. Yeah, a small little clip on the back, and normally a short little screw. To replace that if it hasn't damaged the case. And again, batteries. Most batteries are either non-serviceable or they will be soldered into the monitors, and a lot of the single gas may have and disposables may have small lithium ion or alkaline batteries in the back of them. The move on more modern instruments now is getting more modular, so you're starting to see batteries that are independent, that can be removed from servicing points of view. They're becoming easier to change than previous, so needing less interrogation of the main board on the instrument. Other parts that you may need will be cases, screens, and main boards, although those parts are generally you will not be able to touch or procure in most cases unless you have been manufacturer trained, as this will break the warranty if you're going to the meter and trying to replace displays, and then that will void any warranty, so beware of that. Going on, we've got other key considerations when running a gas detection service organisation. Obviously, staff, like with any other operation, it's key to have dedicated staff that have the customers' requirements at heart. So good training, manufacturer training on the instruments and services is required. Good turnaround. Most customers now expect a fast turnaround, somewhere between 2 days and 5 days. You'll need to keep a large inventory of spares and consumables, and that will depend on the amount of range of monitors that you are looking to service. But typically, sensors, as well as the other consumables we mentioned before. Sensors have a lifetime, so you need to predict how many you're going to require each month, because you will not want them sitting on the shelf or in the refrigerator in many cases, because they do deplete even while being stored. So you want to give the maximum life once they are installed and you're putting them into your customers' meters. Again, quality systems. I'd always recommend at the very minimum that any service organisation would have an audited quality system such as ISO 9001. This allows you to ensure that your processes, both internal and external, are followed. as well as any warranty repairs, warranty returns back to the manufacturers. It gives a good grounding. It also gives confidence to your customers ongoing. Waste, you will need to consider the waste that is generated. You have your WEEE directive here in the UK, the proper disposal of any batteries, the sensors themselves, and any plastics will need to be considered, so to ensure we're protecting the environment. And then you've always got to consider and make sure you're on top of any ongoing developments and new products that are coming to market, and making sure your staff are trained on the service and the supply side, any key functions. Going forward, there's many products released each year, so an ongoing program with your service organisation is always going to be required. So thanks for listening to me today. I hope I've covered the basics of the service provision for portable gas detection. If you'd like to download Point Safety's brochure, it's available, should have popped up now. If you do need to discuss any portable detection requirements, then our team are here, more than happy to go over your requirements and be here at hand for anything you need. So I'll pass you back over to Chris, who will go over a few of Spantech's products and services there.
Thank you, Paul. Thank you for that talk. We have some questions. We'll take the questions at the end of this short talk, and hopefully we'll cover all the questions. If we can't cover any of the questions, we will certainly come back as well with more detailed answers should that be required. So every question will be answered, and every question will be answered in its entirety. I would just like to quickly explain about the one particular aspect that Paul mentioned on, which is the source of the calibration gases required in the servicing. This is something that Spantech has been involved with for 30 years or more, in fact, and I just want to present two or three solutions with comments on. So the obvious one, and the one that is probably most common, is cylinders. We here are particularly talking about ppm and toxic and reactive and difficult gases in this talk. So I wanted to just put up the two options that we supply, which are probably pretty typical from the point of view of the decisions that have to be made by the end user. The higher quality cylinders that we use, which are particularly relevant for, I'll say, ppm level reactive gases, we have for 20 years now almost supplied the Portagas equipment, Portagas cylinders out of Houston, Texas, supply on a worldwide basis. These come with the various accreditations for ISO that you would expect of the highest level cylinders. They are typically used by international organisations who want to adhere to the strictest international standards, up to ISO 7866, and they are they're supplied. They are uniquely treated and coated on the inside, which was a process developed by Portagas 20 years ago with their founder Kushek Parekh, and that's why they will supply even down to 1 ppm level H2S, for example, cylinders. Each of the bottles is uniquely treated, and on the inside, the outside, each is barcoded, tracked, and typically reused as well, which is becoming progressively, of course, more important. Look at the environmental considerations. I've been in the Houston factory and I've looked up the history of this individual cylinder, and with occasionally you get one that's been used 30, 40, 50 times, and you can track the history of that. Issues with cylinders in general, of course, on an international basis, are progressively becoming more difficult to ship. Of course, a lot of people will be familiar with the hazardous goods restrictions, and the cost of shipping has gone up. So these are also a consideration. The other type of cylinder that we sell worldwide is our Spancam brand, which has been sold since the 1990s. A lot of it's filled in the UK, but we now have trusted partners in India and the US who can fill. Again, if we can do that, it does cut down on shipping to these other markets, which is a great advantage. Just like the Portgas cylinders, we typically get some aluminium cylinders, and we tend to be regarded as people that specialise in disposable cylinders up to 110 litres. Certification is provided for all the cylinders with Spancam, often batch certification, but it is important that the certification is reliable and traceable, and we've been doing this now for 25 years. So the choice of your cylinder will depend on your requirements, maybe on your company policy, your locale, and what is expected of you if you're servicing insurance by the end user customer. And as I say, often the green Portgas cylinders are mandated by international companies like the petrochemical companies for these trace reactive gases, say 5 ppm, 10 ppm chlorine, for example. There is, however, nowadays other solutions to some of these issues, and I'd like to just show you one, which is gas generation. We are an equity partner with a company, and have been again for almost 20 years, based in the US, that makes these handheld gas generators that generate gases actually from 50 parts per billion, typically up to 50 ppm. Although with the ammonia, it does go considerably higher. These high-end units will give you multiple flow rates that you can dial in, or multiple ppm levels that you can dial in the range that's dictated by the cell we're using. The standard cells typically are from 0.5 ppm to 50 ppm, but there are other ranges available. As I say, there is in particular a PPB range. These generate advantages. People talk about economics quite a bit, because once you've got the unit, the ongoing cost supply of your gas is very, very low, and there's no inherent shelf life anymore. So with the aluminium cylinders we've looked at, for ppm toxic, you might have a 6 month or 1 year for Portgas shelf life. With this, the only reason that you're worried about how old your cell is if you want to keep the NIST certification current, because that is only a 12-month certification. And that again, it depends on your view as the end user. You might not consider that you want to do that, or you might want to do it, in which case there's a service charge every 12 months for just bringing it back up and recertifying it. So these are very easy to use. They're also very easy to transport. There's no gas inside here. There's a liquid, so I carry this around with me all over the world. Well, I used to carry it around with me all over the world when I could, and hopefully we'll be able to again soon. But that's not the fault of the instrument. and I would just take this to the check it in, and take it on the plane with me. And I would have a little suitcase, Pelican case, that would generate up to 8 different gases from the single unit. Each gas is, of course, an additional cost. In addition, some of these are ATEX approved, some are not. So there's always a discussion about which is the best. It doesn't affect the cost of the instrument. It just affects which instrument you might choose for other reasons. Powered simply by AA, or in some cases AAA batteries. So and can produce a range of gases at this ppm or even ppb level. Ozone, for example, chlorine dioxide, all quite challenging to put a ppm level in cylinders, but also hydrogen, ammonia, hydrogen sulfide, nitrogen dioxide, and other such gases. As I say, in principle, all of those can be put inside a single unit, inside a single Pelican case. Very easy to transport, very cheap to transport, and of course environmentally friendly, because now you're no longer having waste in the form of metal cylinders. This is also much easier to deal with from that point of view. So also to say, there is a low end of these generators. These are very small. These are pockets. These are pocket size. These fit into your trouser pocket if you want, or your shirt pocket. They typically operate as a bump tester, in that you'd get a small 90-second outflow of gas to bump test an instrument. They're not certified in the same way, therefore, but and you will have a fixed output here. So when you order the cell, all of our cells have a microchip in, which tell the instrument their characteristics and their lifetime of use. And you typically will specify between 1 and 25 ppm. And when you put that cell into the top of the instrument, into the screw area at the top, it will know what ppm it's going to be producing. This is an electrochemical generation, and has 4 options of chlorine, hydrogen sulfide, hydrogen cyanide, and hydrogen. Whereas in the larger units, you have more gases available, particularly in the ozone, which is a UV lamp generation, or permeation tube technology. But the idea of the slow end is it's very cheap to use, very cheap to maintain, and it's almost getting to the point of being a personal item, because of its size as well. We also, as Spantech, have for 30 years sold replacement gas sensors. You can see a little group there. At the top, our first and longest living partnership is with what City Technology has now become Honeywell. We have working with customers to provide sensors at the lowest possible price for their needs for many, many years. And we try a number of initiatives to do that. We have a biggest business in the electrochemical sensors, but we also supply palisters and IR sensors as well. We do various campaigns to try and provide sensors at low pricing, in particular by having focusing on a particular sensor each month. We can club together orders, so people ordering relatively small amounts don't get penalised in the same way as you might do otherwise on a per unit price. And by working on 6-monthly or 12-monthly requirements, we can guarantee pricing and that's the best value for people. And this particular month, we're looking at 4 RXVs and trying to supply those at low cost for people. If you want further information on what's going on, there's a couple of things you could do. I would very much encourage you to look at the webpage, but also on the LinkedIn and Facebook pages that we have, where you will automatically get notified of what's going on in these offers, and be able to take advantage of them in the best possible way. That's basically been our method of working for many, many years, and with the experience we have, it's also important to say that we can provide technical support and technical advice yeah, you might struggle to get directly from the manufacturer, particularly if you're not a bigger customer. So we have that experience going right back to the first prototype of the first city cell in City University. So that's a fair while ago, but within my memory. So on that, I will close this part of the talk. We have actually ended up bang on time. 10 minutes was reserved for questions, and we will look at that. I have put up for available 3 brochures that you can download. One is the Spantech portfolio, which is a very simple document that covers our products. Anyone interested in the cylinders, I've got the Portugas brochure there. You can download. That's quite a big, unfortunately, 5 megabyte download. And I've also got the ACD brochure as well, which covers the different instruments in a very, again, in quite a simple, concise way. And those three products, those 2 portfolios are there for you to download as you see fit. And on that, I think we can go to the questions, Sam. Bring them up on the screen. I will. Paul and I will try and answer these as best of our ability. Paul, I think the first one, I think we'll. I think you mentioned already, but in a short way. But could you take that one? I think.
Let me just go over that question.
So the question is, isn't it a requirement for the person calibrating the monitors to have training with manufacturers?
No, it's not. It's in terms of standard calibration, as every monitor will come with a user manual which details manual calibration, and also there is documentation available. Then calibration can be carried out by the user, so that they do not have to have manufacturer training. I would always advise training, against those user instructions, and some knowledge on protection before coming out. But if you go any further than just calibration applying gases, so any servicing activities, then manufacturer training would be required to do that.
Very good, thank you. The next question should pop up on the screen now. It's the Teflon tubing and the stainless steel question. The Teflon tubing is used for most reactive and corrosive gases. Should stainless steel regulators be used? Standard regulators are nickel-plated brass, and it's possible for false readings on bump and calibrations due to reactions with the regulator. So I think there's been a number of follow-ups actually on the chat on this, but the basic answer I think is yes. Yeah. At Spantech, we do, I haven't mentioned it for lack of time, but we've sold the Portugas regulators for the last 20 years. They all have options of non-corrosive and corrosive models. Whenever we sell regulators, we do typically we try and ask the question about the gases being used, so that we do cover this. And I think, Paul, in your chat, you mentioned that you typically use stainless steel.
I always find, Chris, that if your organisation standardises on all.
Paul, did you mention in the chat about typically you're using stainless steel at point safety as a matter of course?
Can you hear me, Chris? Yes. We will always use stainless steel across the board, whether it's demand flow regulators or.
Right. Have I, Paul? Can you hear me? Can anyone hear me?
I can hear you. Sorry, Chris. I was just mentioning. I don't know if anyone else can hear me. I was just mentioning I standardise on stainless steel across the board demand flow or fixed flow regulators, because it just avoids the possibility of someone using an incorrect regulator, depending on the gas.
I think there's been a bit of an issue with Krish's
Right.
connection, so we'll try and proceed with the questions.
Yeah.
So the next one was, I think, accidentally highlighted a little earlier, but it was from Fadley, who typed, "I'm end user of gas company in Middle East. How much surrounding temperature affecting accurate readings of the gas tester / detectors? Some gas detectors that are installed in the plant are frequently giving a fault alarm during the summer season with a temperature of 35 to 49 degrees Celsius. Is this the suggestion to avoid this kind of fault to reoccur?"
In terms of that environmental condition, it is always a problem when you've got high humidity and high heat. You can use them for flammable detection. You can use open path or infrared solutions out there, which will generally eliminate that. But toxics, you do tend to have a problem. There is high temperature versions of some sensors, but in most scenarios where the environmental conditions are extreme, then you need to increase your calibration routine and frequencies in order to know, and also your sensors will need to be replaced far more regularly.
Okay, right. I'll mute myself again now that Krish is back.
I dropped out for some reason there. Let's just say, watching the danger of these things. Do you want to put the next question up, then we'll hopefully take it on. Some users lose the calibration cap. Is it okay to bump test using a plastic bag over the sensor? Or is it okay to calibrate using a plastic bag over the sensor? Okay, yeah. So that's a simple answer. That shouldn't be done.
No. Ultimately, if you're not using the correct connection to the meter, you cannot guarantee that the concentration at the sensor heads are being reached. And it's just a liability for a false calibration, which ultimately is dangerous. So if you haven't got the correct equipment, get it.
Yes, so that's I think a general rule we've seen over the years of anything to do with a gas calibration or dealing with high pressure cylinders and anything of the like, from a safety point of view as well. Okay, next question. What do you think about about systems to go on which go to the market, saying 3 years without calibration? What do you think of that strategy for selling?
There tends to be a number of meters coming out. Most of the main manufacturers or the traditional ones are not offering that type of solution. Some of the smaller companies are trying to use that as a market differentiator, and I'd always say it's a life safety piece of equipment, and unless you're applying test gases to it, you don't know it's working, whether it's got a self-test button or any self-test routine that's being professed. Ultimately, unless you apply a gas to it, you don't know it's working. The same with a multimeter. If you're not applying a voltage or a current to it, you don't know that it's reading the correct reading. So I'm always skeptical of these devices.
Okay, and the next question from Colombia. Oh, Jesus. What do you advise to calibrate a pH3 monitor range 0 to 2000 ppm? The phosphine is very dangerous, so we will not use calibration concentrated recommended by the manufacturer, which is 1000 ppm. So the manufacturer says we should use the sensitivity of pH3 to carbon monoxide. Doing it this way, we would need a 3000 ppm CO gas, which is more safe than pH3. Can you give any advice?
Personally, I'd also say 3000 ppm CO is quite a high level of CO. Obviously, not as dangerous as phosphine, but I've mentioned in my chat before, I'm going to reply to Jesus my email, because I just want to check with our technical specialist here on that specific application. So if I can get access to that question at the end of the seminar, I will reply to him directly.
Yes, we will sort that out, of course. Absolutely. Right. Any more? So, question from Rincy. What are the consumables used in handheld gas generators? Well, for most of the gases involved, it's an electrochemical cell that is the consumable, aside from the AA batteries or AAA batteries. That, depending on the gas, will either technically be the electrode or the electrolyte. But the principle is that the electrochemical cell will be consumed. That means that after a certain amount of time, you will be prompted to replace the electrochemical cell. Now, that could be, depending on the instrument and the cost, that could be anywhere between a 2-hour cell and a 100-hour cell. Obviously, economies of scale mean that the 100-hour cell is very much cheaper per hour of use, but the 2-hour cell is ideal for people who maybe bump test a few instruments every month, because, as I said, the lifetime, there's no shelf life of the cell, so the 2-hour cell might last a very long time. In the ozone, that technology is using a ultraviolet lamp, which needs to be serviced regularly to keep it clean, and it will eventually, of course, die after a few hundred hours, and will be consumed, therefore. However, if it's kept clean and serviced every 100 hours, it does last considerably longer. And for the ammonia generators, the large ppm ammonia generators, as opposed to the low ppm, then you're using a permeation tube to get the 1000 ppm levels. There's a PR, as with the ozone, a PID feedback that regulates the output to the dialed-in ppm that you've set. But the permeation tube will typically give 8 hours supply to the generator. So it's a $20, $25 consumable in that case. So it will give you a day's supply, and it's very cheap. This is that's the basic. They're basically the consumables. So it does depend on the way that you're doing it, and the amount of gas and the choice of electrochemical cell does depend on how much gas and how much use you get out of it. The idea being that you should be able to choose an option that is economically most sensible to you. Okay, next question. How critical is the flow on the regulator to sensor readings? Paul, do you want to take that one? That you're more experienced, maybe.
All I would say on that is each sensor and each monitor will have an advised flow rate, and it's been tested by the manufacturers for that flow rate, for calibration purposes. So I would never deviate from it. I haven't tested them personally outside of those flow rates, but you can get distorted readings because the monitor will work on a countdown when it's taking its sample, and if your flow rate's not high enough, it might not have flooded the sensor enough with the target gas by the time that it's taking its reading, so it might not have given it the correct amount of time. So I would always say ensure that you do use the correct flow rates in every scenario.
Yeah, I mean, I think one of the more common problems we see on return sensors is that, in fact, the sensor's been poisoned, and sometimes can be by too much flow rate, too much gas, and sometimes you can recover that by flushing through with inert gas, but sometimes you can't. And I think sensor manufacturers would probably say that's one of the more common return reasons they get. Okay, next question. Any more questions coming up on the screen? I think that's probably it. Looking at it, well, that's fantastic. That leaves us only 5 minutes overdue. Thank you for all the questions. That was very, very lively. You will get a thank you for a note by email for attending. That will include contact details for me and Paul, but it will also include a link to the recording of this seminar, so that you can go back and listen again if you want to, but also you can forward it to colleagues that you think might have an interest. And that recording will be available for some weeks at least. If you want to hear more about these seminars in the future, this is the second we've done in the series. The first one was on gas generation. Then do look for our webpage, but particularly look for the Spantech LinkedIn page, where you will automatically be receiving news of these seminars, and that will and how to register for them. Hopefully that will be good, and we shall hopefully see you for the next seminar, which will be in approximately 2 months' time. As I say, if you want to know more, do join us on LinkedIn at the Spantech page. Thanks, thank you, and that link will be on the email you get from us at the end of the seminar. So thank you very much. Thank you to Paul. Thank you for Sam, who's been working in the background organising this, and as always, done a fantastic job. Thank you, gentlemen, and have a very good afternoon, or very good evening, or a very good morning, depending on whereabouts in the world you are. Thank you. Goodbye.
Thank you. Thank you again.